introduce. I want to introduce J. Cliff Smith. He is one of our ethical hackers at Parameter. I have known Cliff for going on 10 years. We've been doing this company for about 10 years. Back when he was about 13 years old, or felt like it, he was doing web audits for us, and he had a high career in information security. And then one day he decided to test for law school and got a full ride scholarship and ended up becoming a lawyer. We thought all was lost. This is almost a drama. Until one day, Cliff woke up and said, I want to be a hacker. He came back to Parameter. He has been with us now going on 3 years?
Year and a half full time.
It seems like forever. Very, very smart individual, a good friend of mine, a great coworker. Please welcome Cliff Smith.
All right, thanks so much, Dave. Everybody hear me good? All right, so this is Something Died Inside Your Git repo. We're going to talk about the mental errors, the patterns of thought, and the habits that impact the quality of code your programmers produce from a security perspective. We are going to get down in the weeds. We're going to roll in them. You'll probably get poison, sumac, whatever. But the goal, the end product, hopefully, of this conversation is improving the way you think about security, the way you think about code, and the way you think about application security. So let's do a quick poll. How many folks here are, or would describe yourself as, in some capacity, programmers? Good chunk. All right. System admins, network admins, the like, network engineers? Few. Any managers or other blue teamers that have something to do with the SDLC? Okay. What about pen testers, red team? Okay, few. How many people are experienced with web apps, just out of curiosity? Okay, good. That's my background, so a lot of the examples relate to web apps. So, bit about me. As Dave said, I am a lawyer. I'm a recovering lawyer. By the way, that's a nephew shot. He's the one in the Superman outfit. I'm the one with the crazy eyes, in case that wasn't clear. So, I have been programming since I was a kid, and pretty much my whole career, except for when I was writing bankruptcy motions in the Eastern District of Missouri. God love it. My career has been about bad code. I've been writing it, reading it, trying to understand it, breaking it, or fixing it. So that is what drives this for me, and that's what actually drives my career in pen testing. I'm also one of the organizers of OWASP St. Louis. We have a booth out front right outside the escalator. OWASP, great organization. Follow us. We'll talk about what we're doing and what we can do for you. So the whole subject of code smells, if you've heard that term before, it comes from the book Refactoring by Martin Fowler. And originally, a code smell was basically an anti-pattern. It's a pattern in code that indicates something is wrong and is going to cause you maintenance problems. In the book, there's a list of 30 or 40 of them, actual individual code smells, these anti-patterns. But the theme among them is that either your code was poorly designed to begin with, or more likely, during the lifetime of your application, the code you have has deviated from its original design, and it's time to just toss a chunk of it out and rewrite it. And these smells, I think, a lot of programmers find useful because refactoring, it's kind of wishy-washy. It's not concrete. There's no test you can do that says your code needs to be refactored. And a similar thing can be said for security. It's not always so obvious that you're writing your code in a way that's going to cause security problems. So to adapt this idea to security, this idea of looking at anti-patterns, we're actually going to expand it a little bit. So code smells, for purposes of our conversation about security, could mean structural problems in your code. They could mean errors in the way your programmers are thinking, the way they're approaching problems. And third, they could be patterns in the application behavior itself. There are anti-patterns in behavior as well as anti-patterns in the code itself. And we'll talk about this in detail. Whenever you have one of these smells in your code, there are 8 of them that we'll talk about today. What they mean, yes, you're likely to have security problems, but more specifically, either your team has gaps in their understanding of security, or they're engaging in some bad habits that lead to mistakes. Remember, programming is an art and a science. If you want to read about the science, go read Knuth. Awesome. Geek out. I'll do it with you. It's also an art. You're not just writing code for the compiler or interpreter. You're writing it for the next person who comes along, maintains it, and edits it. All right? It's a human endeavor, always remember it. And there are three causal links between these code smells and the actual things that get you breached, the actual vulnerabilities. First, if you got one of these smells, you chose the wrong approach to solving a problem, so you made it harder on yourself. You're probably making it more difficult than it needs to be. Second of all, if you made one of these mistakes, it means you probably don't quite understand the problem as well as you should, which means that it's more likely you're not going to solve it right. And the third one is the one I find the most interesting. If your code either behaves in a way or is structured in a way that's indicative of one of these problems, you've actually just given a signpost to your attackers. You've shown them where the weak spots are in your code, right? By the way, how many people in this room have imposter syndrome? No. Yeah, every one of you is a liar right now, because everyone who works in this industry, I'm convinced, at least 80% of us have imposter syndrome. Who doesn't know what imposter syndrome is? Anybody? It's an anxiety that people have that's based on a persistent fear that they really don't know anything. They're a fake. Any success they've had is by accident. And all of their professional colleagues are about to find them out any minute, and their whole career is going to come crashing down, and they're going to die poor and lonely. That's imposter syndrome. A lot of people in security and IT have it. You want to know what mine localizes itself on? It's this. This is how I operate when I do a pen test. I have written a lot of bad code in my life. So when I see a programmer making a mistake, I recognize it not because I'm a super genius hacker, but because I've made that mistake myself. So if I'm good at my job, it's not because I'm a great hacker, it's because I'm a terrible programmer, and I can at least recognize the mistakes I've made when other people make them. So, anyway, enough with the psychodrama. I read a rule somewhere that says if you're giving a talk on tech or InfoSec, you have to include the relevant XKCD. So here we are. This is one of my all-time favorite XKCD strips. They compare antivirus software on voting machines with a teacher who wears a condom while teaching. Because, okay, yeah, condom equals safety and security, but the fact that you feel it necessary to do that means something has gone completely wrong in your thinking, right? And the real problem is not, the fact that you're wearing the condom or whatever it is you're doing. It's whatever thoughts you had in your head that made you think it was necessary to do that. That's what we're going to try to do today in this talk, is fix those mental errors that happen before the vulnerable code gets written. One last little bit of motivation. Any grammar nerds in the audience? I recommend you look away from the screen when this next slide is on. I'm seeing grimaces. Is anybody twitching? Is anybody about to faint with these horribly confused words? Right? If you're cringing right now, it's because you've reached a level of unconscious competence with these grammatical rules and with these loose and two, all these words that get confused. The goal is for the same reaction, at least you are having right now, to be the same reaction you have when you see code or software that doesn't operate the way it should. Get so familiar with the right way to approach security, the right way to approach programming, so that it doesn't even cross your mind to do things wrong anymore, and so that it feels wrong to write code that is dangerous. So that's all the waxing philosophical. Let's actually dive in. So here is a story from a pen test I did of a web app last year in the summer. So, nothing particularly complicated in this application. Users can upload information, they can type in some text, they can upload a photo, they can, write a title, they could drop a pin on a map or something. So, what's the first thing I did? I looked at the file upload. Are they restricting the types of files I can upload? Obviously, it was intended to store images, an image that would be associated with that piece of content. No restrictions on what you upload whatsoever. What's the first thing you do at that point? Web shell. Upload a web shell. Upload a script that lets you execute shell commands on the system. So I do that. I do, dir c:// it was an IIS server. I see some RSA private keys in the root of the server's hard drive. Some really interesting stuff. So okay, cool. That deserves a Qdoba burrito bowl. I go to lunch. I come back and I say, okay, what else can I do? I start thinking about Privesc and whatever else. My web shell is gone. And the node, the piece of content associated with it, has been deleted from the database. I email the client and say, hey, have I tripped some kind of defensive system or something? The answer comes back, oh no, one of our programmers actually is watching and he's seeing what you're doing. So he's cleaning it up and fixing the mistakes as you go along. So thanks very much. Appreciate your work. Keep going. So not only am I shooting at a moving target, I have to make sure I'm documenting everything when I find a vulnerability so that I can get it in the report. But this is actually one of the most interesting pen tests I've done specifically for that reason, because I could watch the programmer try to defend against the attacks that I was doing in real time. Here's an example. Sure enough, there were no defenses against stored cross-site scripting. I throw a script tag in there, bing, alert box. Okay, cool. 30 minutes later, that attack didn't work. They implemented this fix. You see an opening script tag. Did that work? No. Okay. The attack I tried after that was, let's do an image. Let's give it a bad SRC and an on-error attribute that'll fire off some JavaScript when the browser tries to load that image. Bing! Alert box again. Then they implement another fix. We're going to reject input that matches that regular expression. So open angle bracket, some letters, some other crap optionally, and then a close angle bracket, trying to filter out HTML tags. Did that work? No. This is what I actually did. I just omitted the closing bracket, the closing angle bracket. There's a /p tag or a /div tag or something like that after my text, so it still looks like an HTML tag. Malformed maybe, but the browser still renders it. My attack still works. The defense they tried at that point, they say, okay, he can't do script tags. If we can stop him from putting HTML attributes in here, we got him. We're safe. So that's the regex they used. Open angle bracket, some letters, and then a space. That didn't work either. What I did was just replace the space with a slash. Firefox still renders this. It still gave me the alert box. So I was tempted to just keep doing this over and over again, but I said, okay, the pen test is done. We're going to actually write your report now and give you some actionable advice, hopefully. What's the pattern? What's the anti-pattern that this programmer and I were engaging in during this pen test? We were playing cat and mouse. Never play cat and mouse. All right? The pattern here, the behavior that's problematic, is designing a defense that is tailored to the specific attack, the specific sequence of steps the attacker took to breach you, to pwn you, whatever. Instead of doing that, design your defenses based on the vulnerability. What is the fundamental conceptual weakness in your application that allowed you to get breached? And in some cases, as you all know, because a lot of you are web folks, sometimes the weaknesses are not weaknesses in your code, they're weaknesses in the protocols that make the web work, which are 30 years old by now. So either way, if you want to understand what the specific vulnerability is, what is this vague, wishy-washy, conceptual thing I have to fix, try broadening your functional requirements. A functional requirement for this past app might have been user can enter text, and it'll display on the website. Say it just slightly differently. User can enter text, and it will display as plain text. If you phrase it that way, you know what problem your application doesn't solve correctly, and you know how to go about solving it. Always implement solutions that are correct, theoretically and provably. If need be, you should be able to go to the RFCs that make your technology work, or even write a mathematical proof if you're so inclined, that shows that your defense works in all cases. Right? That's the goal anyway. It's not always that simple, but these are the types of defenses you should be looking for. Second example, I apologize, there's a lot of stored cross-site scripting here. How many people have written code like this, where you have a page in your application that needs to initialize a map or do some kind of JavaScript stuff, and you just throw a script tag in the end of your body and just say, okay, map.init 123 Main Street. That's a user's address, so we'll just spit it out there in the script tag. You should be twitching and fainting right now. Why? Thoughts? I bet you would all be just screaming if I wrote the word eval on this slide. When you do this, you just did eval, because you put user data directly into your code. It's possible to do this safely, but do you want to walk that tightrope? Do you want to take the risk that you're going to forget to escape a single quotation mark, that you're going to forget to escape a /script tag which is going to terminate your JavaScript even though it's inside a single quoted string? Do you want to take the risk that you're going to miss some of that? No. Here are a couple other ways to approach this problem. One, you could separate that data into a separate HTTP response. Load it separately with AJAX. Now that hurts performance, but one benefit of that is you can do things like turn caching on for all of the HTML pages, the JavaScript, the static resources, and turn it off for all the data gets pulled down through these AJAX requests. That helps protect your user's data. If there's something sensitive, the browser's not going to cache it. An even nicer approach, and I think this is my favorite, base64 encode that data. Put it inside a script text template tag. That tells your browser, don't render this stuff. It's not code. Just ignore it until you get to a /script tag. We can prove that's safe. The only way to break out of a script tag is with a closing script tag. Angle brackets and slashes are not part of the base64 alphabet. At least angle brackets aren't, I know. Right? So the smell, the pattern for this one, I call this separation of church and state. Right? The church is your code. Right? It's beautiful. It's holy. It's only touched by programmers who are the clergy of the code. Right? It's version controlled. It's unit tested and pen tested. Right? You use static analysis tools on it. Data belongs to the people. It's democratic. It's messy. You never know what you're going to get. The people sometimes do weird things, as we all know, in the United States of America right now. Separate data from code whenever it's possible, and I'll bet you it's almost always possible. By separate, we mean put them in different channels of processing. Here's another test you can use. If there's any point where you can look at something, text, whatever, that's part of your application, and go character by character and say, that's data, that's code, that's code, that's code, that's data, that's code, that's code. If there's ever a string that's held in memory or on the hard disk that has a byte of code and a byte of data right next to it, you're doing something risky. Right? Separate them into different channels of processing. Prepared SQL statements. Who uses them? Anybody? I'm going to assume that means the rest of you don't do web applications with databases on them. But no, seriously, it's by far the best defense to SQL injection that exists out there in the general case. You send the database server a query with question marks in place of the data. You send the data separately and you leave it up to the database server to interpolate the code into the data into your joins or whatever it is you're doing. All right, it's a much safer way to do it. Be also wary if there are functions you're calling that toe this line a little bit. Printf. Who knows what a format string vulnerability is? If you take printf is a function that will take certain character codes and use them to interpret arguments. And I won't blab through the whole thing, but simply by printing a string written by your user, passing it as the first argument to printf, if they put a %x in there, they're going to start reading memory addresses from the call stack. They're going to know return addresses. They're going to know call arguments of the function that called your code and so on. So be careful whenever you have any functions that blur that line for you. Remember that safety of data is meaningless out of context. Never say, I'm going to reject any input that's unsafe. Because your data is not used only in one way throughout your application. Sometimes it's injected into SQL queries. Sometimes it goes to the browser in an HTML page. Sometimes it's in a SOAP request in some kind of XML document. You can't just say, I know what input is safe and unsafe, because the safety of data depends on the context in which it's used. So don't rely on that. If you're escaping control characters, that's the last resort. There's almost always a better way to do it. All right? Next example. Okay. So this was an application I worked on that already existed. It was already coded and everything. It was not a particularly complicated application. Again, a bunch of forms, store some text, store some data. It appeared in input tags, text areas, whatever. If you looked in their database, you would actually see HTML control characters escaped. So if you were at a MySQL shell and typed select blah from blah, you'd see, today I watched, end quote semi, The Pirates of Penzance, end quote semi, by Gilbert and amp semicolon Sullivan. That's what was actually in their database. Works, again, if you're just putting it into HTML pages. Well, during redesign, some of these forms had elements change from inputs to text areas and back. We were also using WKHTML to PDF to actually render PDFs of these pages server side. There was JavaScript that ran in the browser that replaced the form elements with spans containing the actual text. How should that JavaScript code be written? For the jQuery programmers out there, do I read the HTML out of my tag and then inject that into the text of the span? Do I read the text out and tell jQuery to treat it as HTML? I still don't know the answer, and this was 2 years ago when I first looked at this. And again, what if this data is being used in a different kind of context? Confusing as all get out, very easy to make mistakes. So the pattern, the smell for this one, is a solution decoupled from a problem. All injection type attacks, whether you're talking about SQL injection, cross-site scripting, whatever, they are presentation layer problems. It is the unsafe interpolation of data into a certain context. So don't solve that problem way back 10 years ago when you're accepting the user data. Put the solution where the problem lies, right? I think of this like, imagine an airport that had the security checkpoint at the highway off-ramp. That's not where the problem is. The problem is people bringing dangerous things into the terminal. So check people at the terminal, right? So you can just make it very easy for your programmers to make mistakes. Data integrity, model state, things like that, they're model layer problems. Enforce them in the model, right? Put the solutions where they belong, right? And your goal should always be to build a secure API that your application programmer or the next programmer who adds on another feature can easily use securely to build a good application, right? Solve problems in a place that matches where the problem comes from. All right. This one is a bit of a public confessional. So this was the first actual tech job I had. I'm not even going to pretend that it's not me, it's me. I did this stuff, I know. So this was for a small firm. It was my dad's firm. He's an architect. And I was building a project management and timesheet system. Who here's read The Camel? Learning Perl. Anybody? I see a couple. I'd read Learning Perl. I knew how to write code in Perl, so I said, okay, I'll do this. I'll save my data in a text file. I'll have lines that say entry. And I'll say key equal value, key equal value. You know, the project data, the user data will just sit right next to each other in this text file. I was reading the whole text file on every page load, just throwing it all into memory. If a change was made, we make one change in the data structure in this big old array, and we rewrite the whole text file. That took about 30 seconds for every time the user clicked a save button or an add button. Right? I don't know what's most amazing about this. The fact that it kind of sort of worked, the fact that they actually used it for a while, or the fact that they paid me to do it. So what does any of this have to do with security? Well, the most embarrassing part of this whole little story, first version of MySQL was released 8 years before I did this. So there was absolutely no earthly excuse for me to be writing this text-based database business. The pattern for this is don't solve important problems from scratch. Storing information in a database, that's an important problem, and I tried to solve it completely on my own. I just decided to cowboy it and do it with a text file. So specifically, an important problem is one that is either fundamental to what you're doing. So something like parsing an HTTP request, that's basic and fundamental. If it's easy to get wrong, if it's tricky, or if it's something that is likely to create a vulnerability if you get it wrong, if it's something that has inherent security implications. Authentication, that's an important problem. Everything crypto is an important problem. Now there was a talk, I can't remember who it was, somebody on Iron Geek said that don't roll your own crypto is a little like abstinence-only sex education. The reason I disagree is that safe sex is a lot simpler than good crypto. Good crypto is difficult and complicated. So you should not be writing code completely on your own to do these things. If you think to yourself, well, surely somebody has solved this problem before, rely on what they've done. Rely on what they've written. If there's a good third-party solution out there, if your web application framework has a tool for protecting against cross-site request forgery, use it and test it for that matter. At the very least, Google it. Read what's on Stack Overflow. Look if there are any papers released at ShowMeCon or Black Hat or wherever else talking about attacks against this technology, or white papers about how to defend against this type of attack, right? Don't make it easy for yourself to make mistakes. Also, anything in the OWASP top 10, those are well understood, well documented vulnerabilities, and there's very, very good data and research out there about how to defend against them. Read what's out there. Even if you write your own solution, rely on the people who've come before you. Right? This next one, there's not the whole example solution pattern for it. I call this next problem the abstraction trap. Who knows what abstraction means in a programmer sense? Okay, so it's where you write code that allows the next programmer who uses that code to interact with it at a convenient level of complexity. That's CS textbook speak for it. The point is you write an object with an interface, and certain details are abstracted away. The person who uses your class doesn't have to care how you implement it. Right? So say you're writing a chessboard. You might write a function on there that allows somebody else to just say, okay, white plays rook takes d4. You don't care how the pieces are stored. You don't care if they're classes in some OO inheritance structure. You don't care if they're single characters in a two-dimensional array. You don't even care if you're playing classical chess or some variant like Bughouse. The interface defines what you care about. You don't have to worry about the implementation details. The problem here is that there can be vulnerabilities and problems in the details we abstract away. And that can mean anything. The problem can be that you're using third-party code that has features you didn't know about, that you didn't realize are there. I was doing a pen test on a web application that used a plugin, a third-party plugin, commercial open source software. It had the ability to set the user's session ID. Why? I still don't quite understand. But they didn't know that was there, and that created a session fixation vulnerability. That was a problem. Does anybody remember reading about the timing leaks in RSA with the Chinese remainder theorem? Anybody? No? So RSA, a lot of the details are beyond my knowledge. I won't try to explain it in that much detail, but RSA is built around modular exponentiation. You raise a number to an exponent, and then you take it mod whatever, mod m. And one of the algorithms for computing that value is the Chinese remainder theorem. The problem is, if you use the Chinese remainder theorem in your RSA implementation, the attacker can get some information about your private key based on how long it takes the Chinese remainder theorem to run. And there have been practical attacks using this timing leak against, I think they were against embedded devices mostly. The fundamental thing to fix in your thinking, if it's not your code, it don't mean it's not your responsibility. You have to take responsibility for it. And also, just because a piece of code might meet your functional requirements, it might do what you need to have done, that doesn't make it a secure and safe solution. Even strlen, the C library function, that function has an early return in it. I'm sorry, not strlen, strcomp, comparing two strings. The standard GNU libc implementation has an early return. So if you're writing some kind of crypto library and use strcomp to check string equality, you've just created a timing leak. Do you know that that timing leak isn't exploitable? They're hard to exploit, but have you tested for it? Did you think about that? This is hard. And that example partly illustrates why subject matter knowledge is so important. You have to learn about security, understand how common attacks work, so that you know what to look for, so that you know what kind of problems can arise. So keep in mind. Another example, mobile applications. A lot of mobile programmers don't know that by default, I think both iOS and Android will cache your HTTP responses if you write an app that pulls something down from the web. If sensitive information is being pulled down through your RESTful API, that information can be stored on the user's mobile device. So, all right, this is a quick example. This was a vulnerability in an open source CMS. Take a look at this code. It's either Python or pseudocode, depending on what mood you're in. Anybody see a problem here? I see some nodding. Any thoughts? Anybody? We've got this code here that checks if the user is an admin and then rejects the request if not. Do you see that in the delete user function? No. The programmers just forgot to write it there. So I can't remember which CMS this was, honestly, but if an attacker just sends a delete request, they'll be able to delete a user even if they're authenticated as an unprivileged user. So the pattern here, wet code. What does dry stand for? Everybody. Don't repeat yourself. Edgar Dijkstra, right? Wet, write everything twice. No, don't do that. Don't do that. I mean, the point here is, especially when you're talking about security features, don't make your programmers remember to write the same line of code every time they create a new URL in your application or write a new feature. Right? In this example, it would have been much better if you had some way, whether through a decorator or through something else, to say, okay, all functions in this section or in this part of the URL structure are administrator only. You write that once, and you don't have to rewrite it every time. Don't leave yourself one forgetful moment away from a critical, serious vulnerability. Speaking of Perl, does anybody remember what Tim Toady stands for? There's more than one way to do it. What does the Zen of Python say that's contrary to that? Yeah. It says that. It also says there should be one, and preferably only one, obvious way to do it. All right? Think of your programmers like your customers. Right? You want to make your software, or the core of your application rather, easy for them to use. There should be one obvious way to build whatever feature they're building, and that obvious way should be the secure way. Right? Don't leave the way your code is supposed to be used vague and confusing so that it's easy for your programmers to make a mistake, so that they have to dig down into your documentation, read through every line of code that they're going to be calling, every line of code in your core, to understand where, the security vulnerabilities are. Right? Build a secure core API for your own use. And remember, security features should always go as close to the core as possible. Here's another example. This is a web app I did recently. They were accepting media uploads, again, images and SWIFT files. Individual file upload, I try to toss up there a exe, bat, ASPX, PHP, whatever, it gets rejected. There was also a bulk upload feature where you can upload a zip file. Sure enough, the extensions and MIME types weren't being checked for the files in the zip file. Right? This is actually right at the intersection of two of these smells. It's wet code. They were making their programmers repeat that, make sure this isn't a dangerous file snippet every time there was a URL that accepted a file upload. It's also, it's failure to put the solutions where the problems are. The core section of your application that accepts file uploads is the section that is responsible for making sure those files are safe. Make it difficult for your programmers to do weird things. Very few web applications, or rather, web applications that accept media type uploads from your user should almost never be accepting PHP files or exe files or anything like that. Make the oddball, security dangerous behavior difficult to implement. Make it easy to implement safe behavior. Right? So don't worry about putting security checks too deep into your application. If your programmers want to do something weird, it should be hard. It should take some effort, and it should take some documentation. Right? Don't repeat yourself, especially with security features. This was a vulnerability in, again, commercial open source software. So this accepted file uploads. This is a small snippet. So a slug, a small section of a URL, a short text identifier that identifies a piece of content, there was this function that validated the slug before it saved it to the database, or rather before it printed it to the screen. If strpos slug less than doesn't equal false, and quote doesn't equal false, return false. Say that the slug is not safe. And then we were doing, in JavaScript, show image, echo slug. Any PHP programmers? Nobody. That's good. That's good, actually. The problem is, in the PHP manual, there is this big red warning on the page for strpos. And it says, if the needle is not found in the haystack, this is going to return Boolean false. If the needle is found at the front of the haystack, it's going to return 0. In PHP, 0 equals false, because they're both falsy, to use the Python phrase for it. This big warning says if you're checking the return value of this function, use the triple equal operator. It's the identity operator. It also checks type. So, yeah, mistakes happen, believe me. Like I said, I've made this mistake before. The problem is, any other programmer who looked at that code would have caught that. Don't secure your code with just your eyes only. I never, at Parameter, when I'm writing a pen test report, I never send it out before at least one other person has read it. I wouldn't do that. I don't want it to be that easy for my mistake to make it all the way to a client, especially when somebody else could fix it. The number of ways that this could have been caught, any static analysis tool, PHP Lint would have caught this. I tried it. If you're using PHP Storm, it'll give you a red squiggly underline, I believe, if you try to do str pause bang equal without using the triple equal operator. If you're actually doing VAs, vulnerability scans and pen tests on your code, you'll find it that way. Manual code review will find it. If you're unit testing, you'll find it that way. If you're fuzzing, you'll find it. So, I don't care what you do. That's your business. But I don't mean that. I don't care what your process is for application security, but have something in place so that one programmer doesn't make one mistake and create a critical vulnerability in your application. Give yourself a chance to catch these issues and fix them. This is the last one. This is, before I get into the details, this is probably the most vulnerable piece of software I've pen tested. When I did a retest on this, it was by far the most improved piece of software I've done a retest on. So that's very much to their credit. This was an application for a financial institution, mobile app. It was using a RESTful API. HTTP requests were going back and forth. So we go get account details and my account number. Cool. All right, here's your account details. Here's your social security number, by the way. They were caching that social security number. That response was being cached. So if I steal somebody's mobile device, I have their SSN. All right, first critical vulnerability. I tried changing the account number, shock of all shocks. Again, a lot of what we do as pen testers is just knock on doors and see what happens. See if we can get the app to use the technical term, barf, and do something it's not supposed to do. I get a 404, invalid account number. Okay, sounds all right. I keep changing the account numbers, and suddenly I get a message that says access violation. What just happened? We found a valid account number. About 10, 15 minutes after this, I had a script that was enumerating every valid account number in this bank's database. That's a problem, right? Then we have an operation we can do on an account. We can reticulate your splines, right? Because everybody knows what that means. We get a message that says success. We try adding some markup, looks like an XML or HTML closing tag, into one of the values in the operation. And we get, whoops, sorry, error. XML document couldn't be parsed correctly. By the way, here's a stack trace, and here's the exact position in the XML document where the error was encountered. I was directly manipulating XML messages going to their core processing system. I banged my head against this for hours and couldn't get it to actually do something to an account that wasn't intended to be done, but suffice it to say, this is a bad thing, right? So the commonality between all these vulnerabilities in that example is that they have to do with information. I call this mind the information gap, right? The client and server are on a mutual need-to-know basis. There's absolutely no reason why the mobile device needed to know the user's social security number. It wasn't even used in the application. It wasn't even shown on screen, thank God. Don't send that to the mobile device if it's not going to use it. The account number example. The client was telling the server something it should have already known. That almost always is indicative of an access control issue. If you're asking me for that information, that means you're probably going to trust the answer I give. So the fact that a full account number, aside from that in and of itself being dangerous, the fact that a full account number was being sent immediately said to me that that is worth checking for an access control problem. Sure enough, it was there, right? So you can leak sensitive information, you can give the attacker a roadmap, and you can create access control problems if the client tells the server something it should already know. I see this on almost every web app or mobile app I pen test. Error messages should be limited in detail. Can anybody think of a valid reason for a stack trace to be sent to a user? I can't. Never. Never. That information is for programmers and maintainers, not for the users. So the only information that should be in an error message that's sent to your user is an error happened, here's the basic nature of the error, could not contact server, here's what to do if you want to get help. Try again later, for example. Another sort of sub-piece of this trap is that the client should never be treated as trusted, right? It's easy to fall into that trap because sometimes the client is the piece of our application that gets the most work, right? A lot of the times the client is the secret sauce. And whether it's a web app, a mobile app, whatever, sometimes the client is even more complicated than the server side of our application. So it's easy to think when you're spending so much time putting your hands in that code that it's mine, it's secure, I control what it does. Nobody can manipulate it. That's not true. Your bad guy might have access to your source code, even if it's closed source. Maybe they can steal the code. Maybe they can bribe somebody in your organization to give it to them. Maybe they can reverse engineer your application. And no matter what, bad guys also got a good chance of reading the network traffic and just figuring out how the API works, breaking it apart, and writing their own client to try to make it work, right? Don't trust something that is sent to the server just because it came from this beautiful client that you wrote, all right? So mind the information gap is the way I put it. So summary. Number one, don't play cat and mouse. Solve problems once and solve them correctly. Number two, separate church and state. Code and data should never live right next to each other. They should never be sitting in the same string so that I can go byte by byte. This piece of information is code, this piece of information is data, and so on. Put them in separate channels of processing if it's ever possible. Solve the problems and security issues in your application at the layer where the vulnerability exists. Solve presentation layer problems in the presentation layer. SQL injection, cross-site scripting, whatever, put those defenses in the presentation layer. Always put the security features as deep in the application as you can. Right? Don't solve important problems from scratch. Crypto, authentication, anything fundamental to the way your application works, something that's likely to cause security problems if you get it wrong. Access controls, right? Research best ways to do it. See if there are tools out there to help you write that code and make it work well. The abstraction trap. Remember that just because you didn't write the code doesn't make it not your responsibility. Read up on the features of third-party code you're using. Make sure you're not missing something you need to do. Make sure you're not introducing a feature you don't want your application to have. Wet code. Don't repeat yourself. When you solve a problem, solve it once and solve it globally. For example, if you're implementing a cross-site request forgery defense, find a way to write your code once so that any post request or any non-safe request method gets rejected unless it's got this correct CSRF token in it. All right? Code secured by a single set of eyes. Whatever your organization is doing, find a way to have either a vulnerability scanner look at the code, a static analysis tool, have somebody else read it, do code reviews, pen test it, whatever. Don't let one programmer make one simple mistake and let that vulnerability get all the way into your production application. Finally, mind the information gap. Remember that the client and server are on a mutual need-to-know basis. And never, ever send detailed, uncensored, unredacted error messages all the way to the client. Remember, by the way, in this example, if I didn't have these detailed error messages, if these error messages weren't written that way, I would have had no idea that I'd hit on a valid account number. The vulnerability is in the error message, right? Although at the same time, they should have been blocking, well, I mean, they did block it, but they told me why they blocked it, which was the problem. So, all right, so a few final thoughts. It's very important to understand the conceptual root of each type of vulnerability. Is it failure to correct a problem that inheres in the web browser, the way the browser works? Is it failure to handle user data safely? Is it an injection layer problem? Is it a business logic problem? And use that understanding to approach the problem of writing a defense, of fixing the vulnerability. Again, it's 2017. Any web app pen testers in here? Kind of, sort of. Have you all had a SQL injection vulnerability in the last year you found? Ben's giggling, so I think the answer is yes. Sadly, no. Okay, good for you and good for your clients. But remember that all hacking, it runs on information, assumptions, and trust. So if you're assuming something, manage that assumption. Either set yourself up so that you throw an error if the assumption turns out not to be true, or find a way to handle it gracefully, right? Don't be afraid to Google simple questions. I have Googled, how do I defend against CSRF more than once in this past year. WACTEO. Did anybody hear that acronym? We are customers to each other. So the person who writes the core of an application should treat the next set of programmers as their customers, right? Treat it like you were selling your piece of software to another programmer, right? Write your software so that it is easy to write secure code. You're not going to send an application to a client, at least hopefully not, to another programmer where you're going to have vulnerabilities if you use the code in the most obvious way. So that you have to wade through 10 pages of documentation to find the secure way to use core features of the application. Study the specs. This one, I think this is a cultural shift we need in application security and in programming. I think people should be encouraged to read the RFCs, whatever documents they are that make the technology work. I will bet you more than once since I've been at Parameter, I have gotten a cross-site scripting attack to work because the programmers forgot that there were 70, 80, 90 different on attributes that can be used to run JavaScript in the browser. They thought it was just a script tag, you know. People forgot that, for example, MySQL in some configurations can run a shell command with XP CMD shell or whatever that function was called. A function that should not exist, by the way, obviously, but the forgotten features and the forgotten ways to use a protocol are a source of a lot of vulnerabilities. And it's good for red teamers and pen testers to study that as well, because we know how to do evil things when we study that type of information. And remember also that secure code is correct code. A lot of these examples, and a lot of the examples we see in practice, are vulnerabilities that could be classified as correctness problems. Again, if you're stating your requirements correctly and understanding them right, your code is vulnerable because it doesn't do what it's supposed to do. It's wrong, it just happens to manifest itself as a security problem because an attacker can make it do something that's damaging to your organization. All right. And also remember that a lot of the practices that we're talking about here are just good coding practices anyway. If you're keeping your nose clean, dotting your I's, crossing your T's, all those habits are going to serve you well when it comes security time. So, that's all I got. Any questions? All right. Thank you very much.